A simple DC motor has a stationary set of magnets or wire-wound electromagnets in the stator. The armature has one or more windings of insulated wire wrapped around the core. The ends of the wire winding are connected to the commutator. The commutator allows each armature coil to be energized by an external power source. The commutator is a rotary electric switch that periodically reverses the current direction between the rotor and the external circuit. It is composed of multiple metal contact segments on the rotating armature of the motor. Two or more electrical contacts called brushes, made of a soft conductive material like carbon, press against the commutator. The brushes make sliding contact with successive segments of the commutator as it rotates. The windings on the armature are connected to the commutator segments. DC motors have several components that are similar to AC motors. The components that are similar are windings, air gap, bearings, frame, fan, and terminal box. DC motors operate on DC current, and the current is applied to the rotor, armature, rather than the stator as in an AC motor. The DC motor rotor is called the armature. DC motors have a commutator along with brushes on the motor shaft for applying DC current to the motor armature. The DC motor commutator is a mechanism used to switch the input of most DC motors and certain AC motors. It consists of split ring segments insulated from each other and from the motor shaft. The motor armature current is supplied through stationary carbon brushes in contact with the revolving commutator, which causes required current reversal and applies power to the machine as it rotates from pole to pole.